Okay, so today we're talking about something called the remainder theorem. Obviously, it's all about the remainder. And like in long division, like if we think back to our warm-up, the remainder was like the thing at the very end. And same is true for synthetic division, right? We talked about the remainder is the very last number in synthetic division, okay, that you get. So this is kind of a mathy definition that you've got here. It says, if a polynomial f of x, so just like some function, is divided by x minus k, so let's take note that the remainder theorem works when you're dividing by x minus k. I would say that is a linear factor. So we can use this under the condition that it's being divided by a linear factor. Like our warm-up problem, we were dividing by a quadratic, so the remainder theorem would not necessarily apply here, okay? Because we haven't met the condition that we're being divided by a linear factor. Then, what about it? Then the remainder, r, is f of k, which is really mathy. So let's try to make sense. What does that mean? R is your remainder. What's f of k?
The function times.
No. What's f of x? F of x is just a fancy way to write y, right? I say that over and over again, and I hope that my students remember that silly little, it's a fancy way to write y. Only because we don't want to see it as multiplication. Function notation is not asking you to multiply anything. It's just naming a function, isn't it? Like calling it a different y. Okay, so that's really important. This, when we say f of k instead of f of x, it's still just a y. Okay, so we're saying the remainder is the y value when x equals k. Because f of x is y for any given x that you would plug in. So if I ask you to do f of 5, you plug in 5 for x and you get an answer out for y, right? So instead of plugging in a number in the theorem, they're just saying plug in some k, whatever you get out for it, that's your y value for that x. Okay, so this is y when, ooh, that looks messy, when x equals k is what I meant to say right there. Okay, now x equals k. How's that related to my linear factor that I divided by? That's the 0 of the linear factor. Okay. 0 of the linear factor. Okay, so if I divide a polynomial by x plus 3, the remainder is the y value for the polynomial when x is negative 3. That's what the remainder theorem says. Okay, so what's the big deal? Okay, I'm going to phrase it a couple of ways. One awesome part about this is you can now use synthetic division, the thing that we learned yesterday, pop it into the synthetic box and do add down and multiply until you get to the end. You can now use that as a way to evaluate your polynomial. If you think back to section 4.1, when you guys were graphing polynomials, you had to create or generate a table of values, like a list of ordered pairs. And you would just you would use something I would call direct substitution, which I'm going to show you here in a little bit. And you would plug in x and you would work it all out and you would get a y. That works, but you could also now do synthetic. When you divide f of x by x minus k, it's the same as evaluating f of x when x equals k. So that's kind of like restating the remainder theorem in another set of terms. Maybe a little less mathy, but still a little bit of math in there. So dividing f of x by the linear factor x minus k ends up being the same thing as evaluating f of x when x equals k. And we're going to do some examples with like polynomials and numbers, so I'll talk more about like, okay, what does this mean in the end about like the evaluating of the polynomial. All right, the final thing that we're going to write down before we do some examples is it's going to be a spoiler. Okay, so spoiler alert. Okay, this is a spoiler for later on in the chapter after our quiz, but I'm going to give you this spoiler today. Getting that thing to go away. Working at it. Sorry. Suspense of the spoiler. Spoiler. When f of k equals 0. So remember, f of k is also your remainder. When your remainder is 0, you have a factor. And if you have a factor, then you have a 0 or an x-intercept. So that's like going to be super great for us because we're going to be looking for, eventually, with our polynomials, what are our x-intercepts? This part right here where it says when the f of k, when f of k is equal to 0 because that's the remainder, okay, when the remainder equals 0, that you have a factor, that should make a lot of sense to you, like, even without it being a polynomial. If I asked you, like, what are the factors of 6? 1 and 6, 2 and 3, right? And why are those numbers factors and 5 isn't a factor? Yeah, because 5 doesn't go in nicely. Would it be like a decimal that I would have to multiply by, or a fraction? If I divided 6 by 5, I would have some kind of like remainder, right? So when the remainder is 0, those things are what we consider nice, and they're the factors. So that should make sense to you. And then we know from parabolas already that in factored form, we can find the zeros. You just set your factor equal to 0, and boom, that's one of your x-intercepts. So we're going to build on this idea of the remainder theorem and use it to help us find the zeros or the x-intercepts of our polynomials. Okay, so let's do some examples so we can see how this works. Pull this down so you can see it better. These are going to be like the first few problems on your homework assignment. I would say this is pretty basic once you like understand what the remainder theorem is asking you. It says evaluate f of x, which is 4x cubed minus 2x squared minus 5x plus 11 when x equals -2. Now, we have another way to do this. We could take the -2 and we could plug it in for all the x's, right, and work it out. That's how we would normally do it. That's called direct substitution. You just substitute it in for x. But what we're saying today is if we do synthetic division, we will get the correct y value. So I'm going to set this one up with synthetic division. So I'm going to make my synthetic box. I always check my polynomial that I'm dividing. What's the highest exponent? X cubed. So I have to have all the terms that come below it. I have to have an x squared and an x and a number. And make sure I put those coefficients in. If one of them is missing, put a 0. So that's going to be 4, -2, -5, 11. Yep, -5. And normally, like yesterday when we were doing synthetic division, it would say like divide by some x minus k, but now it says evaluate when x equals -2. So this would be the same as dividing by, what would my linear factor have looked like? X plus 2. It must have been an x plus 2. So like in this one, when it says evaluate for x equals -2, do you have to change its sign? No, you have the 0 of that linear factor, right? The 0 is -2. So we're just going to put -2 on the outside. Okay. So drop in your coefficients. If it says x equals, put that number on the outside. If it gives you a factor to divide by, then you got to use the 0, so change its sign. Okay. All right. Add down and multiply. So always remember this one, the first leading coefficient, there's never anything to add. You can treat it like there's a 0 right there. You'll just drop your 4 below and then multiply. 4 times -2 is -8. Add down to get -10. Multiply, we'll get +20. Add down, -5 plus 20 is +15. And 15 times -2 is -30. Add down and we'll get -19. Are we okay with my synthetic work? Okay. Okay, now if we were dividing polynomials, we would want to go back and put all the x's back. But we're being asked to evaluate the polynomial. So you just look at this bottom row. Which one of these is the y value? By remainder theorem. The remainder, right? So what we're saying right here, oops, circle that one right there, is when x equals -2, y equals the remainder, -19. That would also mean for us like -2, -19 is a point on the graph. Now I'm going to pull over my calculator on my screen and I'm just going to like verify that this makes sense. So remember before we did it with synthetic, I said we could have just plugged in -2 for all those x's, right? So 4 times -2 cubed minus 2 times -2 squared minus 5 times -2 and then plus 11. Did I get all my signs right in there? Okay. Oh, it is -19, isn't it? So it's not like one, like obviously tonight you would practice it with synthetic, but now it's just like giving us another way to evaluate a polynomial. And if you were doing something like without a calculator, this sometimes can be hard for us without a calculator because you really have to pay attention to order of operations, and it feels like you're doing like a lot of things, like raise it to the third, multiply by 4, square it, multiply by -2, multiply, add all the like terms, when I could also just drop them into synthetic and add down and multiply, add down and multiply, add down and multiply. I'm doing the same thing over and over again. So I kind of really like synthetic. Okay, can you try one and see if you can get to the correct answer? Oops. Try to get to the right side. So see if you can do f of x equals 4x squared minus 10x plus 21 when x equals 5. And try it with synthetic. Okay. So try it the new way. Seeing good work as I move around the room. Okay. The remainder is 71. So that's saying, I could write this now, like I could do a function notation. F of 5, the function when x equals 5 equals 71. That's also saying the same thing when x equals -2, y equals -19, right? This is the mathematician's shorthand way of saying that. We also know that 571 is a point on the graph. If I'm thinking about end behaviors, like beyond 5, does it just keep getting bigger? Maybe the right side is rising. That would make sense with my positive leading coefficient, 4. If we plugged in 5, we would do, and did direct substitution, we would get a 5 squared, which is 25, times 4 is 100. And then we would minus 10 times 5, which would be minus 50. So then 100 minus 50 would be 50. And add 21, and wouldn't we get 71? Yeah. So it's just another way to do evaluations. Okay, so that's basically remainder theorem, just saying the number at the end is the value of the function. So according to my spoiler, if we're looking for x-intercepts or we're looking for zeros of our polynomial, what are we going to really want our remainder to be? 0, because if my y value is 0 in my ordered pair, that point is going to show up on my x-axis, right? So it's going to be an x-intercept. So that's another reason why I'm always putting my smiley faces in my zeros. They make me so happy because that's an x-intercept. That's a point I can plot on my graph. I want to know what my zeros are. So we're going to be searching for those in the second half of the chapter. All right. Let's see. There was one similar to this on the homework, but this is a good thinker problem for us. We'll do a little high-level brain work here. Okay, thinking outside of the box of just evaluate. So if you're dividing those two polynomials, can you find k such that your remainder will be 0? Maybe kind of converse with your pods. If you remember doing this on the homework, how did you manage it? What could you do? Think about the things we've been learning in 4.3 that might be helpful here.
What's the question?
I will offer one hint. Try using synthetic. I mean, that's new. We've learned it. Could be helpful. Have I put all the information that this offered me into my synthetic division yet? What did I not include in my work that I know? The remainder will be 0. Put both my these in there. So what does that then mean, you know? If you get 0 right here. Yes, you know that the y is 0, but like in order to find k, what do you know else about this problem that you can fill in? That the number on this line must have been 36. There's nothing else I can add to negative 36 to make it equal 0, right? Okay. Hang on, we'll get to it eventually. Okay, if that number is 36, what else do you know? Addison? That you would have gotten this number by multiplying the bottom right here, right, by negative 4. And so you're thinking, well, what is 36 divided by negative 4? Negative 9. So this number must have been a negative 9, which means above that must have been a 0. And where did this 0 come from? Something times negative 4, right? So you took like this number right here times negative 4 and you got a 0. What does that number have to be? 0. Oop, did I put that in the right place? Yeah, I did. 0. Okay, well now I'm kind of stuck, right? But the 1 would drop down in the front. And 1 times negative 4 is negative 4. Therefore, k must be 4. To add down and make that equal 0, k minus 4 equals 0 has to be 4. I saw some people who did it a little bit different, and I like what they were doing. I'm going to erase this k equals 4, put it up here, so k must be equal to 4. I saw some people doing something, like instead of like using the backwards part of this and saying it was equal to 0, they were like doing synthetic, so 1 times negative 4, so this is like k minus 4 times negative 4 is negative 4k plus 16, which is negative 4k plus 7. And then you have to, like, it gets messier, but, like, it should work in the end. That you said it, like, set up your column equal to 0, and then you would know that k was 4. And so it should work that way as well. Okay. Does anybody have any questions about that? You had one similar on the homework last night, but maybe it was closer to the back, so it was easier. Or closer to the front, something like that. Was that on your homework last night, or is that on your homework tonight? It was the last question. Okay. Let's see. Let's do, actually I want to do the next slide. I like this question. Okay. Break, easy, geometry. Okay. I mean like 6th grade geometry, maybe 4th grade geometry, I don't know. If the volume of this box is 64 units cubed, what's that missing dimension? If you have an answer and you could justify it, raise your hand. nice. I got a good little group of hands here. Let's hear from Cole today. What's your reasoning?
I said x is equal to 4.
Okay.
That's because 8 times 2 is 16. And we know the volume is 64. So 64 equals 16x. Which then you just divide both sides by 16.
Because volume is length times width times height. Okay, so you like multiplied the two numbers together to get 16, and then you said, let me just divide that volume by 16, and that's going to be my missing one. Did anybody like think about that differently? Morgan, what were you thinking about in your head?
I mean, to be fair, Kyle just said 4 and then it made sense to me. Well, I was getting it anyway. Like, I was going about it that way, but then once he said that, I thought about it a different way. So you have to, you know that it like the area of that kind of longer rectangle multiplies by 8 to give you 64. So you divide by 8 and that just gives you 8. And so what divided by what multiplied by 2 gives you 8.
You're talking about the front side of the box.
So I knew 4 times 2 is 8, and you have to have 8 to multiply by 8 to get 64.
Okay, so you're saying this area times the height, essentially, was going to be my volume. And 8 times 8 is 64, so 2 times x has to be 8, so x has to be 4. Yeah, that's another way to see it. Did anybody else think about it differently? Maybe you were just even guessing and checking numbers, like you tried a few and then you landed on 4 and it worked. That's fine. Okay. Another way that I think you could do it, that I'm going to show you on this next one when it changes to a polynomial volume, is if your volume was 64, you know, like kind of like what Morgan was thinking, divide it by 8, that's 8, right? So then we know like these two things have to be multiplied by 8. So then take that 8 and divide it by 2, and then it has to be 4. Okay, so you could just divide off the dimensions you know, and then that's what's left over. Oh, sorry, I didn't mean to go to that one. So the last one that I want to show you is, what if instead of telling you the number volume for the box, I know that the volume of the box is modeled by this polynomial, which happens to be cubic. Okay. H is the height of the box. It says tank, but I mean box there, I suppose. Box. And I don't want to say where x is. I'm gonna just erase this whole line. Let's just erase that. I didn't mean that. I should probably reword that. That doesn't really. Ignore. Okay. We don't know the height of the tank or the box, right? Because that's my question. What is the height of the box? This one should be box. Obviously, I'm copying and pasting the question. It's not working well for me. Okay. So that's the volume. The length and the width of the box are x minus 2 and x plus 5. What's the height? Okay. So what we know, okay, is I could draw myself a little box, right? I know, like whatever you consider length and width, this is x minus 2 and this is x plus 5. And I'm trying to find that height. Well, if those were numbers, wouldn't, like what we talked about, like we could either multiply them and divide, or like I showed you on that last one, just like divide off the numbers. Okay. So, do you guys prefer synthetic division to long division in general? Okay, so these are both linear factors, so I could do synthetic division. Watch this. My highest exponent was x cubed, so I have to have an x squared, an x, and a number. I'm going to put in the 1, the 2, the negative 13, the 10. And then if I want to divide off this length, what would I put on the outside of my synthetic for x minus 2? A 2. And if that's really like the side of my box, I should get a 0 remainder. Like these should come out nicely because this should be a factor, like length times width times height, those things multiplied together. So add down. add down, multiply, add down, multiply, add down, multiply. Oh yeah, sure enough, that was one of the dimensions. Okay, so I divided off this one. Okay. Now, this was x cubed. This is now x squared. So this is an x squared, this is an x, this is a number, and this was my remainder, right? Instead of restarting, watch what I can do. I'll just build off my synthetic again. Because I like divided it. It's a quadratic now, right? And now I want to divide off the next factor. What am I going to put on the outside of this synthetic? -5. Add down to get 1, multiply, add down, multiply. Cool. So like they both worked, right? They were both factors. Well, this was x cubed when I started. This is x squared once I divided once. What's this now? X, and the -1 is a number. So what's my missing dimension? X minus 1. It's just like when I took 64 and I divided by 8, there was 8 left over, and then I divided it by 2, and 4 was the answer. Okay, I just individually divided off each side of that box. Okay, if I had divided it -5 and -2, it still would have given me x minus 1. If I would have multiplied x minus 2 times x plus 5 together, like what Cole did, I would have got a quadratic, which then I would have to do long division. But when I did long division, I would have got x minus 1 as my answer. So if you want to find that missing dimension, you would just divide off the ones that you know. Okay. Your homework is short. 7 problems, 6 problems, 6 problems. 38 and 39 are your thinker problems, right? Turn off your phone, walk out of the TV room, and give yourself some time, try some things out, think about it, and come with any questions that you may have tomorrow.